Hello, good morning, students. Yes, good morning, Darshan. Hello, all of you all. Yes, hello, Herman. Good morning. Yes, Sanjay Gaikwad. Amay Mali. Good morning. Yes. So let us proceed, all of you all. Now, first of all, I'll give you all few updates. Students, please listen. In the last lecture, we completed oscillations, if you all remember. Yes. Hello, hello, all of you all. I'm going to start with the discussion of today's lecture. So what I'm saying is that in the previous lecture, we completed the discussion of the chapter of oscillation. Now, MCQs are left of that particular chapter of oscillation. We solved few examples and numericals, all those things that we solved in the previous lecture. But of course, MCQs are remaining. What I will do is I'll confirm with the particular department, and if I get MCQs, we'll solve those MCQs as well. Is that clear? So whatever MCQs are left, don't worry, we'll be solving those MCQs later on, probably by the next lecture if I get it. So I'll give you all update during the next lecture. So I request you all of you all, not to again and again keep on asking in the chat that sir, when are we going to do MCQs? Okay, is that clear, all of you all? Once again, many students have joined right now, so I wish every one of you all a very good morning. And I'm just giving you all update about the chapter that we completed in the previous lecture. Students, which chapter did we complete? We completed the chapter of oscillations, correct? Now we did concepts, we did numericals, but the things that we didn't do, or the things that is left, is nothing but MCQs, multiple choice questions. So what am I saying is that I'll confirm it with the concerned department, and I'll be updating you all that we are going to do MCQs. If yes, from what part are we going to do MCQs? Okay. All right, everybody. Yes. Good morning, Rishida. So all of you all, let us start with the next chapter, that is superposition of waves. This is, I guess, chapter number 6. Chapter number 6, superposition of waves. Now, students, if you all cannot see the entire board, you know what to do. you have to enter the full screen mode. Students, to see the entire board, please enter the full screen mode, all of you all. You'll be able to see everything that is written on the board. All of you all, please enter the full screen mode. Yes, good morning everybody again. Now let us start studying superposition of waves. Superposition of waves, which is chapter number 6. Now first of all of you all, this chapter is closely based on oscillations. This chapter is closely based on the chapter of oscillations. So definitely we are going to use the concepts that we discussed in the previous lecture or previous chapter. Okay, there is some student saying speak loudly, sir. Okay, I'll try to increase the volume. Now hopefully everything is cleared and audible to you all. So let us start with the chapter of superposition of waves. In this chapter, first of all, superposition, as we all know, means combination. Superposition means combination, or we can also say in technically correct language, superposition means vector addition. Superposition means vector addition. So what we are going to do is we are going to combine two or more waves. All of you all, please listen to what I'm saying. Students, please enter the full screen mode, all of you all. You will be able to see entire board. Okay. Now, superposition means combination, which means vector addition. So whose vector addition or whose combination are we going to perform? We are going to perform combination of two or more waves. We are going to combine two or more waves. We are going to superimpose. What did I say? I said superimpose. So we are going to superimpose, we are going to combine two or more waves. And what are we going to vectorially add? We are going to add vectorially the equation for displacement of particle. We are going to vectorially add the equation for displacement of a particle. Is that clear, all of you all? We are going to proceed very slowly. Okay, all of you all pay attention. We are going to proceed very slowly, so you guys don't have any kind of doubts. Now let me talk about the very first concept of the chapter, that is discuss properties of progressive waves. Properties of progressive waves. Now, first of all, let me explain to you all what do we mean by progressive wave. Let us understand what do we really mean by progressive waves. So we can simply say, we'll talk about the definition. We are going to discuss properties of progressive wave, and the first property is the definition. The first property is the definition. So students, a question arises that what is a progressive wave? Okay, so write down the definition, all of you all. Write down the definition. I am dictating the definition to you all. Write down: a wave in which we are writing the definition, all of you all. A wave in which the disturbance produced in the medium the disturbance produced in the medium travels in a given direction continuously. Travels in a given direction continuously. Travels in a given direction continuously. Without any damping. Without any damping. Without any damping. Without any damping. And obstruction from one particle to another, from one particle to another is called as a progressive wave, is called as a progressive wave or traveling wave or traveling wave. It is called as progressive wave or traveling wave. I am going to repeat the definition, all of you all. I am going to repeat the definition. See, I am repeating only for those students who have joined us a bit late. Okay. So students, in today's lecture, we are going to start with which chapter? Chapter number 6, which is superposition of waves. Then what did we learn? We learned that superposition means combination or vector addition. So what are we going to combine? We are going to combine two or more waves. Do you understand this? And what are we going to vectorially add? We are going to perform vector addition of displacement of the particles. We are going to perform vector addition of displacements of the particles. Okay? So this was just the basic. This was the meaning of the word superposition. Is that clear, all of you? Come on, students. Okay. Now, let us start with the first topic. Let us start with the first topic, that is properties of progressive waves. Properties of progressive waves. So students, which properties are we talking about? So first of all, the first property is the definition. The first property is the definition. Okay. So what is the definition? I am going to repeat the definition. Please pay attention, students. Definition says a wave in which the disturbance produced in the medium travels in a given direction continuously. Please highlight the word continuously. Please highlight the word continuously. Once again, what am I saying? A wave in which the disturbance produced in the medium travels in a given direction continuously without any damping and obstruction. Without any damping and obstruction from one particle to another is called as progressive wave. Students, what is the other name for progressive wave? Can we say it is traveling wave? Another name for progressive wave is traveling wave. Students, now the video should be clear to you. Now it won't be blurry. Okay. All right. All right. Come on, students. I hope the first property definition part is clear. Now let me explain the meaning of the definition. So for that, let us consider a huge rope. Let us consider a huge rope. Okay, it's a huge, very huge rope. And one of the end is connected to a pole. So this is a pole and one end of the rope is connected to the pole. Now we are going to hold the free end of the rope, and by holding this, what are we going to do is we are going to move it in upward and downward direction. We are going to move it in upward and downward direction. Okay, if you do that, there will be a crest like structure formed. I hope students you are aware about crest like structures. There is a crest like structure formed. Okay. Yes, all of you all. Okay, let me do something about the reflection part, everybody. Just give me 1 minute, guys. I'm going to do something about the reflection part so that the reflection decreases. Yeah, now I guess there should be very little reflection on the board. All right, thank you guys for the idea, what to do, what not to do, any which ways. We are going to now continue. So students, let us consider this example. We have a very long rope with us, and this rope is tied to one end of the pole. And now at the free end, we produce a crest-like structure. Then we can say if this is a progressive wave. Students, if this is a progressive wave, it means that this crest-like structure will just keep on traveling. Will just keep on traveling no matter how long the rope is. Students, think about this. Practically, if we consider a rope which is, let's say, 100 meters in length, practically, let us say the rope is 100 meters in length. It's a very huge rope, very long rope, correct, all of you all? So if we consider 100 meters length of the rope, and if you consider one crest-like structure, then can we say that after traveling a certain distance, this particular part of the crest will come to rest? Are you understanding this? Because the length of the rope is very large. Since the length is very large, this crest-like structure after traveling will flatten down. In such cases, the wave is not a progressive wave. So now you will ask, sir, then what is a progressive wave? Then progressive wave is obtained only under ideal conditions. Progressive wave is obtained only under ideal conditions. So if this rope and the medium in which the rope is placed is ideal, ideal means no friction or very less friction, okay? In that case, if a small crest-like structure is produced, then it will just continue to travel for infinite distance. This is our assumption. It will continue to travel for infinite distance. Such a wave is called as a progressive wave. Come on, students, do you understand this? What is the meaning of progressive wave? So if somebody asks us, sir, can we obtain progressive wave in day-to-day life? Then the answer is no. Progressive waves can only be obtained under ideal conditions. You get this, all of you all? I hope this explanation of progressive waves is clear to you all. Okay. Now, let us talk about the second property. The first property is definition. First property is definition. So I'm going to rewrite everything neatly so that we can continue with our answer. Guys, the first part is just theoretical, okay? So once you understand few properties, few important properties, we are going to start with the next concept of reflection. So I want you to pay attention. The first property that we discussed is definition. Now let us discuss about the second property. Students, write down the second property. All vibrating particles of the medium, yes, Jagjit is asking us a question, sir, but in ideal case also, the waves should stop after 100 meters. Jagjit, what will happen is, that particular part of the crest is going to reach the end of the rope and will also get reflected and will just move to and fro like this. In ideal situation, it is just going to move to and fro. Do you understand this? So I'll talk about reflection in a while. Students, I'm going to discuss the second property with you all. Write down. All vibrating particles of the medium, all vibrating particles of the medium have same period, amplitude, have same period, amplitude, and frequency. Have same period, amplitude, and frequency. There is one more student asking us a doubt, sir, can the crest travel in vacuum? No, crest, if we talk about in ropes, then crest cannot travel in vacuum because it's a part of transverse wave, and transverse waves cannot travel in vacuum. Transverse waves are part of mechanical waves. Okay. It cannot travel through vacuum. Yes, don't worry students, I'm going to repeat the second point. All vibrating particles of the medium, have same amplitude, same period, and same frequency. Same period, amplitude, and frequency I have written on the board. All the particles will have same period, amplitude, and frequency. Come on students, Try to recall. In the chapter of oscillation, I'm drawing two figures. You need to tell me which diagram have we seen in the chapter of oscillation. This is one diagram. I hope it is now clear, students. I guess there is no lag right now. Yes. Students, this is diagram 1, this is diagram 2. In oscillation, which type of wave have we seen? First one, correct? We have seen first type of wave. We have not seen second type of wave. Are you all able to understand that in this particular wave, amplitude of the particle is different? Amplitude of the particle is different. But in this particular example, amplitude, period and frequency, everything is same. Amplitude, period and frequency, everything is same. Is that clear? Yes. Come on, students. I'm going to repeat it once again. Because there was some connectivity issue, I'm going to repeat it once again. We are studying properties of progressive waves. Are you all able to listen, students? Now, please stop typing. Yes, stop typing in the chats, everybody. Okay. We are studying properties of progressive wave. After learning the definition, we are now learning the second property. And in second property, what have we written? That all the vibrating particles are going to have same period, amplitude and frequency. So to make you all understand this point, I have drawn two diagrams. And what did I ask you? Which diagram have we observed? Which diagram have we observed in the chapter of oscillation? Definitely the answer is first diagram. Because amplitude of all the particles is same and period and frequency is also the same. But if you observe this particular wave, see, amplitude of the particle is different. Amplitude of the particles are different. So I hope you all understand this, everybody. Okay. So I'm just going to erase this because diagram is not required. As I told you, this is theoretical part. So now let us study the third point. Now students, let me know if the first 2 points, that is the definition and the second point, is absolutely clear to everybody. See, if you all have a little bit of also doubt, so you can clear that doubt right now. Sanchit is asking, sir, but at the end of waves, frequency should differ. No, Sanchit, frequency will not differ. I have explained this concept that why frequency will not differ in the chapter of oscillation. So if you have not attended oscillations properly, I would like you to first go through those lectures because this chapter is based on previous chapter. Okay, now some student is asking me to repeat the first point. First point is definition, in which we have said that progressive wave, other name for progressive wave is traveling wave. Then these traveling waves or progressive waves will travel continuously without stopping. Progressive waves are those waves which will travel continuously without stopping. That is what the definition literally says. All right, understood, everybody? Sanjay, I am going to talk about reflection part later on. Okay. Karthik is asking, standing waves are also called progressive waves. See, Karthik, right now your knowledge is incomplete, because of which you are giving us the wrong answers. Do you understand the meaning that progressive means it progresses and standing means it is stationary? So they are not same. Please don't type such answers in the chat. Then everybody will start asking doubts which are not pertaining to the topic. I hope you get this. All right. Moving on. Come on, students. I hope now first and second point is clear. Then now let us study the third point, or rather the third property. Come on students, are we ready? I'm just looking at the chats whether you have any kinds of doubt or not. If not, then we are going to proceed. Yes, let us talk about the third point. Write down, no particle remains permanently at rest. No particle remains permanently at rest. No particle remains permanently at rest. Please write down. No particle remains permanently at rest. No particle remains permanently at rest. Is this property written? Now come on, tell me all of you all. I am drawing a wave. Let us call this point as A and this point as B. Students, can you all tell me that when we talk about point A or point B, either of it, when we talk about point A or point B, what will be the velocity of A and B? Can you tell me what will the velocity of A and B be? Come on students, I'm waiting for your reply. A and B, both the particles are going to be at the end point, students. Both the particles are going to be at the end points. Then can we say its velocity will be 0? Its velocity is going to be 0. Yes, it will be same and it will be 0. Correct. Yes, Rishita, correct answer. It will be same and 0. Come on, once again guys. Once again, everybody on the board, please look on the board. Can we say at this particular point, the particle will be momentarily at rest? The particle is going to be momentarily at rest. And after that, it is going to move in opposite direction. After that, it is going to move in opposite direction. Yes. Now students, I would like you all to pay attention that this particular chapter is very important from your entrance examination point of view. From CET and JEE mains point of view, this chapter and the previous chapter that we have discussed, oscillations, both are very important. So the properties that we are discussing are also very important. All right. So let me discuss the third property. Third property, students, what have we written? We have written no particle remains permanently at rest. Please underline the word permanently. Please underline the word permanently. Have you underlined the word permanently? Yes. And if you talk about these two particles, A and B, or even you can take another particle C. Tell me what are the speeds of each particle, A, B, C. Speed of each particle is going to be 0. Alright, speed of each particle is going to be 0. Chalo, is that clear? Now, students, write down the fourth property. Write down the fourth property, all of you all. Property number 4. Write down. During the propagation of wave, only energy is transferred. During the propagation of wave, only the energy is transferred. Only the energy is transferred. Full stop. There is no transfer of particles. There is, continue in the same point, there is no transfer of particles. There is no transfer of particles. Okay, I'll explain this fourth point to you. But before that, there is one student, Shantanu, asking us how the speed will be zero. Please explain again. Shantanu, as you could visualize in the diagram, that A, B, and C are the endpoints. A, B, and C are the endpoints. And at endpoints, the speed will be zero. I hope third point is now clear, Shantanu. Moving on to the fourth point. Students, fourth point. I'll explain it to you all. Are we ready for the fourth point explanation? So let me erase this and let us now understand fourth property. In order to understand the fourth point, that only the energy is transferred, particles are not transferred, matter is not transferred. So let us consider a container. Students, this container is filled with water and we are looking at the container from the top. So suppose if there is a container placed over here, we are going to look from the container from the above. Okay, we are going to look from the container from the above. So students, the water will completely be at rest. There will be no disturbance. There will be no disturbance. Water will completely be at rest. Now what you do is, you take a small stone. You take a small stone and just release it. So can we say, students, when we release the stone is going to hit the water surface? Because of that, in water, small waves will be produced. When the stone hits the water surface, small waves called as ripples will be produced. So let me just draw the ripples for you all. It will be in the form of concentric circles of increasing radius. Concentric circle of increasing radius. Is that part clear, all of you all? Correct? So now the question arises that if we look at this structure right now, then we are able to feel that all the water molecules, all the water particles are moving in outward direction. What are we able to see? That all the water particles are moving in outward direction. But that is not the truth. Students, what you can do is you can place an object on the water surface which is able to float. Let's say a piece of wood. Let us say a piece of wood. Then you will observe that this wooden particle, wooden object is not going to move in any direction. The only motion this wooden particle will perform is upward and downward direction like this. It will just oscillate in upward and downward direction. Okay, so what do we understand from this? We understand that when the stone hits the water surface, energy is transferred. Look what we have written over here. Look what we have written over here. Energy is transferred. What is transferred? Energy. But the particles are not moving left and right. They are not moving left and right. I hope this fourth point is also clear to you all. Okay. Students, I am going to have a quick revision of all the 4 points. See, I am not revising for my own benefit. I am doing it for you all. I am going to revise all the 4 points very quickly. Guys, what is the first point of the property? The first point is definition. What does the definition say? Definition says that a wave is going to travel continuously without stopping. Then that wave is called as a progressive wave. Second point, particles are going to have same period, amplitude and frequency. Third point, no particle remains permanently at rest. No particle is going to remain permanently at rest. Fourth point, only the energy is transferred. So we took an example of ripples form in water. You can also consider one more example. Yes, Pranav, I'm just going to explain the example right now. Let us consider a rope which is tied to a pole. Now students, we are holding this free end of the rope. Let us say the particle that we are holding is particle O. The particle that we are holding is particle O. Now when you just move this particle in upward and downward direction, what happens? Is the particle going to move left or right? No. The particle is just going to oscillate in vertical direction. See, it is just going to move up and down. But because of that, the wave will be created as such. And after some time, that wave is going to travel. See, after some time, the wave is traveling. Understood? Is that clear? Alright. So I hope now fourth point is also completely clear to you. Sanjay is asking, sir, does these progressive waves have any relation with progressive lenses? No, beta, they don't have any kind of relation. One, progressive waves are a phenomena, and progressive lenses is nothing but an optical instrument. So one is a device and one is a phenomena. They don't have any kind of relation. Okay. So a quick revision of all the 4 points we have done. Quick revision we have done of all the 4 points. The revision, I'm again repeating, the revision is done only for you all, okay? Now write down the next point, the fifth point. Fifth point, everybody write down. Progressive waves are of two types. Progressive waves are of two types. Write down. Progressive waves are of two types. We have done already these waves, transverse waves and longitudinal waves. Students, please write down progressive waves are of two types. Transverse waves and longitudinal waves. Transverse waves and longitudinal waves. Okay. So these are the 5 important properties of progressive waves. Come on guys, let us have a quick recall. Now don't look at the board and do not look in the book also. Without looking, just try to recall, okay? There are 5 important properties of progressive waves. The first one is the definition. Second property, that all the vibrating particles are going to have same period, amplitude and frequency. Third point, no particles will remain permanently at rest. Fourth point, only energy is transferred. Particle does not transfer. And fifth point, there are two types of progressive waves, transverse waves and longitudinal waves. Transverse waves and longitudinal waves. Is that clear? Come on students. Okay. Now let us proceed further with the part that we did in 11th standard, all of you all. We did this topic in 11th standard, and that is equation of simple harmonic progressive waves. We have done this particular topic in 11th standard, but I will once again explain and let us together recollect what we did in the 11th standard. Okay. So guys, the equation was y is equal to a sine of omega t minus kx. What is the equation? Y is equal to a sine of omega t minus kx. I hope you are able to recollect this equation. Let me explain what each and every terms indicate. Y indicates displacement of a particle. Displacement of a particle. Y indicates displacement of a particle. Yes, Aditya. Correct answer in the chapter of sound waves we have done. Correct answer. Next, A represents amplitude. A represents amplitude. Okay. Now students, the minus sign indicates that wave is traveling along positive axis. Please recall, actually all these things you should know. So in 12th standard, what we do is we directly start with the concept based on this particular topic. But I don't want to directly start. I want you to understand and recall. See, students, if you are able to remember this, very good. If not, this is the proper time to understand whatever we are writing over here. So the minus sign in between is going to represent that wave is traveling along positive axis. Okay. Now I'm going to discuss about omega and k. I'm going to discuss about omega and k. Students, omega means angular frequency. Omega means angular frequency. And the formula for omega remains the same, which is 2 pi times frequency or 2 pi upon time period. Students, are you all able to remember these formulas? Come on, yes or no? And K indicates wave number. K is going to indicate wave number. K is given by the formula 2 pi by lambda. K is given by the formula 2 pi by lambda. Yes. I'm going to rearrange the placement again. Yes. Come on, students. What does K indicate? K indicates wave number. And what is the formula for K? 2 pi over lambda. Is this part clear? This is very important. This part is very important, all of you all. Come on, once again. Pay complete attention, all of you all. Let no other thoughts distract you all. What are we studying? We are studying equation of simple harmonic progressive waves. Where have we done this particular topic? In the chapter of sound waves, 11th standard. And what is the formula? The formula is y is equal to a sine omega t minus kx. Y means displacement of a particle, A means amplitude, and minus sign indicates wave is traveling along positive axis. Omega, angular frequency, K, wave number. Formula for K, 2 pi over lambda. Formula for K is 2 pi over lambda. Now, students, tell me, in place of negative sign here, in place of negative sign, if we write positive sign, then what does it mean? In place of negative sign, if we replace it with a positive sign, what does it mean? Yes. Come on. Positive sign means negative axis. Correct answer. Shantanu, correct answer. If there is a positive sign, the wave is traveling along, this part will change. Correct, all of you all? Negative axis. All right. And there is one more formula. Students, please copy this down. Yes. Students, copy this down. And I'm going to give you one very important formula. Yes, Srushti, Om, Yashodeep, Basraj, Surbi, Shravani, Harsh, Rishita, all of you all. Correct answer. And now I'm going to give you all one very important formula. And the formula is phase difference is equal to 2 pi by lambda into path difference. Now, if there is a reflection over here, I'll repeat. Phase difference is equal to 2 pi by lambda into path difference. Phase difference is equal to 2 pi by lambda into path difference. Please learn this formula. Students, this formula is very important from the chapter of optics, light. Even in the chapter of light, optics, we are going to use this formula. Okay. So learn this formula. Mathematically, we can say phase difference can be represented with phi is equal to 2 pi by lambda into x. Any notations we can make use of. You can also write it as phi is equal to 2 pi by lambda into delta x, or you can simply leave it as x, doesn't matter. Okay, students, now I'm going to erase this. This was a part of 11th standard topic. But since it will be used in this chapter, I have quickly told you what is to be done. Very good. Yes. All of you all are giving excellent answers. Keep it up, all of you all. Let us proceed with the next part. And that is, we are going to discuss the concept of reflection of waves. What are we going to discuss? We are going to discuss the concept of reflection of waves. So let us start by understanding for transverse waves. Transverse waves. Now, students, in textbook it is directly given. The conclusions are directly given and explanation is almost negligible. But if we understand how transverse wave will work, then longitudinal wave is going to be opposite of transverse wave. Therefore, we can simply say that if we understand transverse wave, longitudinal waves, everybody should be able to give me the answers on their own. Let us talk about transverse waves. For that, let us talk about case 1. Reflection from fixed end. Reflection from fixed end. Yes, Kshitij, what help do you need? Kshitij is asking, sir, I need a bit of help. So let us know what doubt you have. till the time I am going to complete writing. Reflection from fixed end, that is wave is traveling from rarer medium to denser medium. Wave is traveling from rarer medium to denser medium. Come on. So let's take an example. Of a crest-like structure Kshitij is asking us, is it not phase difference is equal to k into path difference? Correct, Kshitij. And k is 2 pi by lambda, correct? What is k? K is 2 pi by lambda. So we have a crest-like structure which is going to travel towards the right. Now, after some time, can we say this crest-like structure will move a bit ahead? After some more time, this crest-like structure is going to reach towards the end. I hope these three stages are clear to you all. Correct? Now, this is nothing but a point which is tied to the pole. Okay? So we can say this is nothing but a fixed point. This is a fixed point. Now, if this is a fixed point, it will not move. If this is a fixed point, it is not going to move. Tell me all of y'all, if crest is traveling towards right, then all the particles are going to get displaced in upward direction, correct? All the particles are going to get displaced in upward direction. Talk about this particle P. This particle is initially at rest. Then the particle is going to move in upward direction. And then once again the particle is going to come to rest. Are you understanding it, all of you all? So in which direction the particles will be displaced? Upward direction. Okay. So this crest is going to pull this particle in upward direction. Is going to pull the particle in upward direction. But the particle is fixed. So what will the particle do? Particle will exert an equal and opposite force. Particle is going to exert an equal and opposite force. And therefore, this crest, when it is going to reflect, is going to turn to trough. This crest is going to turn to trough. Once again, I am going to repeat once again. In case 1, we are studying reflection from fixed end. That is, wave is traveling from rarer medium to denser medium. So when this crest is traveling throughout the rope, what is going to happen? It is going to pull all the particles in upward direction with it. But when this crest is going to reach towards the end particle is fixed. It will not move. So what will it do? It is going to exert an equal and opposite force. Okay, because of which it is now going to become trough. So what is the conclusion? The conclusion is that when a transverse wave is reflected from denser medium, crest is reflected as trough and vice versa. And vice versa. So generally students, in textbook, when you read the textbook, generally all this explanation is given in a very difficult language. And this is the conclusion. What is the conclusion? That crest is reflected as trough and vice versa. So if trough was traveling after reflection, it would become crest. I hope this much part is clear. So this was a simple structure where we are studying reflection of wave. So where is the wave being reflected from? It is being reflected from denser medium. It is getting reflected from denser. It is traveling from rarer to denser. So denser से reflect हो रहा है. Denser से reflect हो रहा है. Okay. That's the reason I've written here, when a transverse wave is reflected from denser medium. I hope this much part is clear to you all. Come on students, yes or no? All right. So this was a simple example. Now let us consider case 2. Students, let us discuss case 2. Rutuja Pradeep Pisal is asking us that, sir, when the wave is swinged, why does it not form crest and trough both while moving? Means up and down. Rutuja, from what you have asked, what do I understand is that why are we just taking an example of crest? Why not both together? Because we are learning about reflection and we are learning it in an easier way. So what we are going to do is, we are just going to hold the rope. Suppose this is the rope. I'm holding this end of the rope and this end is fixed. This end is fixed. I'm holding this end of the rope. Now what I'm going to do is, I'm going to just oscillate from here. I'm going to oscillate in upward and downward direction. That's it. Then only crest will be formed. If I want to form trough, I'll move from this position downward and once again upward till here. And if I just continuously go on moving it like this, then both crest and trough will be formed. So we are taking an example that will help us to understand the phenomena of reflection. We don't want to make this complicated, do we? Our aim is to make things easy and understand it in a better way. So what is the conclusion of here? The conclusion is, reflection from fixed end, that is wave, is going to travel from rarer to denser medium. Then crest is going to be reflected as trough and trough is going to be reflected as crest. Alright. Moving on with case 2. Alright. Let us proceed now with case 2. Reflection from free end. Reflection from free end. That is reflection from free end. That is, wave is traveling wave is traveling from denser medium to rarer medium. Okay, Rahul is asking, if we take both, the reflection will be reversed. That is, crest trough will be reversed to trough crest. Yes, Rahul, you are correct. If we are sending crest trough, then after reflection will become trough crest. Correct. One more student is asking, sir, when trough returns to the starting point, then it stops. But you need to understand that when trough is going to return to the starting point, ideally speaking, it will not stop. Ideally speaking, it will not stop. Why will it not stop? Because we are talking about progressive waves. Because we are talking about progressive waves. So case 2, reflection from free end, that is, wave is traveling from denser medium to rarer medium. So let us understand this concept now. Once again, we'll start with example by taking a rope. It is now tied to a ring. Rope is tied to a ring which is passing through a pole. Rope is tied to a ring which is passing through a pole. Now let us say we are holding the free end, and once again we just oscillate it from this particular position up and down back to the same position once. Then what will get formed is a crest will be formed. Now this crest is going to travel towards right. So after some time we'll have such a structure. After some more time, the crest is going to reach towards the end. Now tell me, students, what is going to happen? This crest-like structure is going to displace all the particle in upward direction. This crest-like structure is going to displace all the particles in upward direction. So it will try to pull this ring in upward direction as well. Now since ring is free to move, we have considered it as a free end. Since ring is free to move, ring will go up and will again come down. Ring will go up and will again come down. Therefore, after traveling to right, it will be reflected once again in the form of crest. It will be reflected once again in the form of crest. Understood, everybody? So, can you all tell me what is the conclusion? Can you all tell me what is the conclusion? Conclusion is that when a transverse wave is traveling from denser medium to rarer medium, crest is reflected as crest and trough is reflected as trough. Understood, everybody? Yes, very good answer, Prajna. I'm going to write the conclusion. Students, please copy this down. If you all have copied, then I'll erase this and I'll write the conclusion. Yes, Sania, correct answer. Very good, Sania, keep it up. Some student is saying last part explain again. See, if you consider this to be the rope, Okay, if you consider this to be the rope, then this end is the free end. Earlier this was the fixed end, now it is the free end. So what will happen is, when a crest is coming, my hand will also move in upward direction. See, when a crest is coming, my hand is also going to move in upward direction because this is free to move. So when a crest is coming, it will move in upward direction. So it will move in upward direction and come back. So how will it reflect? It will reflect in the same way. It is going to get reflected in the same way. So let us write down the conclusion now. Come on students, are we ready? Can we start with the conclusion part? Conclusion. Now students in the chat, please stop asking what is the weightage of this topic in JEE mains. In fact, I will request all of you all not to ask weightage of any chapter for CET or mains. I will give you the reason. Students, generally all the teachers are going to discuss weightage and everything. How many questions are asked? 1, 2, 3. How many questions? All these things. They are going to discuss it towards the end of the course. So there is no reason for you all to ask it during every lecture. So I request you all that do not ask that, sir, what is the weightage of so and so chapter. All the teachers are going to help you out. Even I will be helping you out. But that is towards the end of the course, not right now. Okay, let us not deviate from the lecture. Understood? Now there is some student asking us, Prachi Joshi is asking us, sir, will you upload PDF of this lecture? Yeah, what I can do is, you look through the video, you click the pictures of whatever I've written, and you can upload the PDF beta. Okay. Alright, let's proceed now. Conclusion. Conclusion is, when... Okay, I'll dictate the conclusion. Instead of writing the entire big conclusion on the board, I'm going to dictate it. Please write down, everybody. When a transverse wave, when a transverse wave is reflected from rarer medium, when a transverse wave is reflected from rarer medium, then crest is reflected as crest. Crest is reflected as crest, whereas trough is reflected as trough. Whereas trough is reflected as trough. Trough is reflected as trough. So students, I am trying to answer all your doubts, whatever doubts you are asking in the chat. And if it is pertaining to studies, I am definitely answering all the doubts. So make sure that you are understanding each and everything, whatever we are discussing over here. I hope this entire concept of reflection is clear to you. Let me just give a quick recap of the concept of reflection. Reflection concept. So tell me, this is a fixed end and this is a free end. Both the troughs are traveling towards right. Both the troughs are traveling towards right. So tell me, in the first case, in the first example, how will the reflection take place? How will the reflection takes place? In first example, the reflection is going to be in the form of crests. Correct? Yes. Excellent answer, all of you all. Yes, Rishita, Pradnya, Ritika, Uzma, Aditya, correct answer. In second example, the trough will get reflected as trough. So now I hope you understand that this structure belongs to case 1 and the structure below belongs to case 2. All right. Now Sanya is asking us, sir, in case 2 you said from denser medium to rarer medium in start, and in conclusion you said from rarer medium to denser medium. Then Sanya, just verify what it is. There is one student asking, sir, I'm actually confused about which is denser medium and which is rarer medium in this case. Okay. Students, stop typing, all of y'all. Stop typing. I'm explaining to y'all which is a denser medium and which is a rarer medium. See, generally we say a medium is denser. Listen to this carefully. A medium is denser if the velocity of the particles is less. Students, pay attention. A medium is denser if the velocity of the particle is less. So if I ask you for light, which medium is denser medium and which medium is rarer medium? What will you say? For light, which medium is denser and which medium is rarer? For light, denser medium are considered to be solids. And for light, rarer medium is considered to be gases or vacuum, correct? Let us talk about sound waves. Students, for sound waves, it is the opposite way. It is the other way around. For sound waves, denser medium is gases and rarer medium is solids. So how do we determine which medium is denser and which medium is rarer? So what is the idea behind that? Is everybody listening to me, all of you all? What is the idea behind determining a medium being denser medium or a rarer medium? The idea is, when a wave is traveling through a medium, if its velocity is maximum, then the medium is rarer. And if the wave traveling has minimum velocity, then the medium is denser. So rarer medium maximum speed, denser medium minimum speed. Rarer medium maximum speed, denser medium minimum speed. Is that clear? Okay. Now coming back to this particular section. Now how do we determine whether the medium is denser or rarer? Can we say, all of you all, that for a denser medium, the velocity is going to be minimum. And in this case, if it is a fixed end, the velocity of the particle is going to be 0. It is never going to move. The velocity of the particle is going to be 0. It is never going to move. Therefore, we'll consider fixed end as denser medium. We'll consider fixed end as denser medium. And we'll consider free end as rarer medium. I hope you understand this. Come on, students. A very important concept I've discussed with you all. So, there is a misconception, all of you all. There is a misconception that denser medium means the particles are very close and rarer medium means the particle is far away. That is wrong. That is wrong. How do you determine denser and rarer medium? Based on the velocity of the wave. Based on the velocity of the wave. I hope this entire concept of transverse wave is clear to you. Manav is saying no sir, please repeat. Okay, I'm going to repeat everything again. I'm going to repeat everything again, guys. No problem. Just make sure that you have understood it. I'm going to repeat it again. Don't worry. Okay. So now I'm going to explain it in another way. Guys, I'm going to throw a question at you all. I'm going to ask you all a question. I'm going to ask you all a question. Tell me, solid. Tell me, solid is denser medium or rarer medium? Solid is denser or rarer medium? Then your answer should be, we do not know. That should be your answer. If I say, is solid a denser or rarer medium? Your answer should be, sir, we don't know. No, no. It will not be denser. No, it is not denser. Abhitanya is answering it correctly. Abhitanya, excellent answer. Abhitanya, excellent answer. Depends. Correct answer. Solid is denser or rarer is going to depend. It is going to depend on which wave we are talking about. You understand this? Yes, information is incomplete. Correct. It is going to depend on, yes, with respect to wave. So if I now say that I am talking about light wave, I am talking about which wave? Light wave. So what will you say? With respect to light wave, solid is which medium? Solid is a denser medium. Okay? But if I talk with respect to sound wave, then solid is which medium? It is a rarer medium. Do you understand this, everybody? Yes? So can you all tell me on what basis did we say that solid is denser and solid is rarer? On the basis of the wave which is traveling in the medium. On the basis of the wave which is traveling in the medium. Okay? So if the wave has maximum speed in that medium, if the wave has maximum speed in the medium, then that medium automatically is a rarer medium. And if the wave has minimum speed in the medium, then the medium is automatically denser medium. So far, is it clear to you? All of you all? See, I'm trying to address all the doubts that you are asking me in the chat. I'm trying my best to clear all your doubts. So is that clear, all of you all? All right. Now coming back to our example. We have a rope with us, and if I'm saying that the rope is fixed, then can you tell me what will the velocity of this point be? Velocity of this point is going to be 0, and it is always going to be 0. Correct? So how is the wave traveling? Wave is traveling towards denser. Wave is traveling towards denser. If it is traveling towards denser, it means it is traveling from rarer to denser. It is traveling from rarer to denser. Understanding it, all of you? And now if I say that the rope is tied to a ring, and if I now ask you all that is this ring free to move? Yes. It means this is which medium? Rarer medium. Then by default, how is the wave traveling? Wave is traveling from denser to rarer. So I hope now the concept of denser, rarer and reflection clear to you. Reflection clear to you. Now how will you combine reflection over here? Let us combine reflection topic here. So we have a crest. We have a crest-like structure. So tell me, in the first diagram, when the crest reaches the end, how will it be reflected? How will it be reflected? It will be reflected like a trough. It will be reflected like a trough. Crest is going to be reflected like a trough. And what can you say about the second diagram? In second diagram, if we have a crest, so how will the crest be reflected? The crest is going to be reflected in the form of crest. It will be reflected in the form of crest. Yes, Jagjit, correct answer. Correct answer, everybody. Keep it up, all of you all. Yes. Excellent answers, all of you all. So hopefully now this is clear. I have explained this concept already 3 times, all of you all. Now it should be clear. Almost 3 to 4 times I have explained this concept. All right, students. Moving on to the second part, that is reflection of longitudinal waves. Reflection of longitudinal waves. Students, can you all recollect example of longitudinal wave? Example of longitudinal wave, can we say sound is a longitudinal wave? Sound is the longitudinal wave. Okay. So if you all remember, just by starting the topic of reflection, I told you all that whatever we are going to study for transverse wave, it is going to be exactly opposite for longitudinal wave. Whatever we studied for transverse wave, it is going to be exactly opposite for longitudinal wave. Okay, so pay attention over here. We are going to talk about case 1. We are going to discuss case 1. When longitudinal wave is traveling from denser medium to rarer medium. When longitudinal wave is traveling from denser medium to rarer medium. Come on, students, tell me. If we replace longitudinal wave with transverse wave, if we are replacing longitudinal wave with transverse wave, what will your answer be? When transverse wave is traveling from denser medium to rarer medium, crest is reflected as crest and trough is reflected as trough. Okay. So if we talk about longitudinal wave, we'll say compression is reflected, opposite guys, opposite. Compression is reflected as rarefaction and vice versa. compression is reflected as rarefaction and vice versa. Now you might think that, sir, try to explain this particular concept in the form of diagram, like how I did for rope. Try to explain it in the form of diagram. But tell me, all of y'all, can we see sound waves? Can we see sound waves? Is sound visible? No, sound is not visible. If sound is not visible, then representation of compression, rarefaction and reflection of those waves, reflection of compression or reflection of rarefaction, is very difficult to understand diagrammatically. And that is the reason I have directly written the conclusion. So students, I would like you all to learn this conclusion. Generally these questions are asked for 1 mark. Okay. So when longitudinal wave is traveling from denser medium to rarer medium, compression is reflected as rarefaction and vice versa. Remember this. Now copy this quickly so that we can start with case 2. Come on guys, come on. All right. Okay, Nishant is asking us, sir, why can't in case 2 be rarer throughout as its velocity does not change? Nishant, it cannot be rarer throughout because the wave is getting reflected. Now when the wave is going to be reflected, is going to be reflected from some medium, okay? From some medium. And that's the reason if you consider that medium as rarer, automatically the other medium becomes denser. Because we're talking about reflection. Is that clear? We're talking about reflection. Okay. Moving on with case 2, everybody. Case 2. So in case 2, what will we say? When longitudinal wave is traveling from, we are going to change this, from rarer medium to denser medium. From rarer medium to denser medium. In that case, compression is reflected as same compression, correct? Compression is reflected as compression and vice versa. Rarefaction is reflected as rarefaction. Now some student is asking, sir, but how come reflection can't take place in same medium? See, I would like to tell you all that reflection only occurs when medium changes. If the medium is same, how will anything reflect? If medium is the same, how will anything reflect? That's not possible. I hope you understand this basic property. Now one student is asking, sir, आपने properties में, okay, see, in properties I clearly mentioned particles of the medium. In property I clearly mentioned particles of the medium. Now copy this down quickly. This is case 2. Copy this down quickly. So hopefully till now, all your minor doubts or even your major doubts, all of them are clear. I have tried my best to read the chats and to explain everything that doubts you are typing. Okay. Yes, we are now going to proceed further. And now write down a very important point. Write down a very important point. Let us write down a very important point, everybody. Chalo, let's write down. Whenever any wave, whenever any wave, whenever any wave is moving from, whenever any wave is moving from rarer medium to denser medium, whenever any wave is moving from rarer medium to denser medium, then the phase changes by, then the phase changes by 180 degrees or pi radian. Yes, Rishita, correct answer. Excellent answer, Rishita. Phase changes by 180 degrees or pi radian. Yes, Pranav, Pratik and Shantanu, all of you all. Correct answers. Okay, this was the first point. Now write down second point, everybody. Write down second point. Whenever any wave is moving from, whenever any wave is moving from denser medium to rarer medium, whenever any wave is moving from denser medium to rarer medium, then phase changes by 0 degrees. Phase changes by 0 degrees. Phase changes by 0 degrees. Yes, Arya, correct answer. Sanjay, Manas, Shantanu, correct answer, all of you all. I'll explain this concept with one example. Let us take one very simple example to understand this. Let us take an example of bicycle and truck. To understand this concept, let us take example of bicycle and truck. We'll generally consider bicycle to be rarer medium and truck to be denser. Let's assume truck means denser and bicycle means rarer. Let's assume this. Okay. Now tell me if in first case truck is at rest. If in first case truck is at rest, then bicycle comes running like this Bicycle comes running like this and hits the truck. Okay, what will happen to truck? Nothing. But there is a high probability that after colliding with the truck, bicycle is going to rebound in opposite direction. Bicycle is going to rebound in opposite direction. So whenever a wave is moving from rarer medium to denser medium, phase is going to change by 180 degrees or pi radian. You understood this example? Okay, let me explain one more example, like similar example but second case. So once again, here we are considering bicycle, here we are considering truck, and now what will be at rest? Bicycle will be at rest. So now tell me, if truck comes running and hits the bicycle, if truck comes running and hits the bicycle, then can we say it is going to take the bicycle along with it? It is going to take the bicycle along with it, then the phase changes by 0 degrees. So it's easy to understand this, that whenever a wave, whenever any wave, it can be transverse wave, it can be longitudinal wave. Whenever any wave is moving from rarer medium to denser, phase changes by 180 degrees. And whenever any wave is moving from denser medium to rarer medium, phase changes by 0 degrees. I hope the entire concept of reflection phenomena is clear to you. Okay? Understood, everybody? Alright, I'm going to erase this. If you want, you can just copy the diagrams down. Just copy the diagram. Now Sumit is asking, sir, for the rope example, after reflection, the crest trough comes back to the hand, then hand will be denser or rarer medium. It is going to remain the same. If earlier the hand was rarer, if earlier the hand is rarer medium, it is going to remain rarer. Okay, it is going to remain. The source of oscillation, remember this, Sumit, remember. Source of oscillation, if earlier it was rarer, then throughout that oscillation, it is going to remain rarer. If the source was considered to be denser, then throughout the oscillation, that source will be denser. So hand is just an example. Better language is source of oscillation, source of vibration. So nature of the source will not change. Nature of the source will not change. Is that clear, Sumit? Understood? Yes. Okay. Now students, I'm going to erase this. And now write down the title as definition of superposition of waves. Students, please write down the title as definition of superposition of waves. Okay, let us start now. I'm going to dictate the definition. It's slightly lengthy definition. So make sure that you don't miss out anything. Students, I will not repeat the definition, so make sure you don't miss anything, okay? Let's start. When two or more waves, when two or more waves traveling through a medium, when two or more waves traveling through a medium pass through a common point, pass through a common point each wave produces its own displacement. Each wave produces its own displacement at that point independent of the presence of other waves, independent of the presence of other waves. Independent of the presence of other waves. Continue all of y'all. The resultant displacement at that point, the resultant displacement at that point is equal to the resultant displacement at that point is equal to the vector sum is equal to the vector sum of the displacements the vector sum of the displacements due to individual waves at that point, due to individual waves at that point. Due to individual waves at that point. Now students, I'm going to give you all 2 minutes. Just go through the definition. If you all have missed the definition, just reverse the video, rewind the video and just go through the definition. Be quick, because after this I'm going to explain this definition to you all, okay? Yes, Sasmit. Thank you, beta. Sasmit, thank you. Those who have missed the definition, Sasmit has typed the entire definition for you all in the chat. Sasmit has typed it. Very good. Okay. All right. Now students, pay attention. Let me explain the definition to you all. Hope everybody is back. Everybody is now focusing again like you were doing earlier. I appreciate your efforts that constantly you are giving me the answers and you are focusing on the board as well. Keep it up, guys. And even students are asking doubts. And when I'm clearing your doubts, all the doubts which other students have, even those doubts are being cleared. So excellent work. Let me now explain the definition to you all. Are we ready, all of you all? Can we start with the explanation part of the definition? Okay, let us proceed. Whenever we are going to have two or more waves, and whenever these waves are going to meet at a common point, then the displacement of that point is simply going to be vector addition. That's it. For example, guys on the board, for example, if we have, let's say, a huge rope with us, and let's say we are producing a crest at left end. On the left end, we are producing crest. And on the right end also, we are producing one crest. So both the ends, crests are produced, and both the crests are moving towards each other. Both the crests are moving towards each other. And let us say this point is P. So this is first wave pulse. Do you remember? A single crest is called as wave pulse. A single crest in technical language is called as a wave pulse. So this is first wave pulse and this is second wave pulse. So wave pulse 1, wave pulse 2. Alright students. Now just assume, for time being, assume this portion is not there. This portion is not there. And the amplitude of the particle here is capital A. Amplitude of the particle here is capital A. So when this is going to move towards right, everybody, when this is going to move towards right, can we say that particle P will be displaced in upward direction and maximum displacement will be A? Maximum displacement will be A. Come on students, I want you all to stop chatting or writing on the YouTube chat. Don't chat right now. Right now we are understanding something, okay? So let's understand it. Like right now we are understanding something, let us understand it. So what are we trying to understand? We are trying to understand the definition of superposition of waves. So there is wave pulse 1, wave pulse 2 in the diagram. But for explanation purpose, right now we are neglecting wave pulse 2. We are neglecting wave pulse 2. So only wave pulse first is traveling. The maximum displacement in first wave pulse is A. So when this wave pulse, that is when this crest reaches the point P, when this crest reaches the point P, it will pull the point P in upward direction with a maximum value A. Getting it? Once again, come on guys, once again. Now what we can do is we can neglect the wave pulse 1. Just neglect wave pulse 1. It is not there. Just wave pulse 2 is traveling. Just wave pulse 2 is traveling. Now when this wave pulse 2 reaches this point P, if the maximum displacement of the particle is A, then this P will also be pulled in upward direction with value A. Correct? But can we say that we are talking about superposition? And superposition means both the waves should reach point P simultaneously. Both the waves should reach P at the same time. So if wave pulse 1 is traveling towards right, wave pulse 2 is traveling towards right, and both of them will reach P at the same time, then what will happen is, literally, let me try to show it to you all. Now if this is crest 1, okay, if this is crest 1 and if this is crest 2, then literally when they are moving towards each other and when they will be merged, when they will combine, there will be a bigger crest formed. There will be a bigger crest formed, and the amplitude of this crest will be 2a. The amplitude of this crest will be 2a. Yes, Daksh, correct answer. Daksh Jain, correct answer. Amplitude of particle P will be 2a in upper direction. Okay. And after this, what will happen is, again both the wave, see, this is wave pulse 1, this is wave pulse 2, it combined. And after combination, they will again continue to move in the same direction. Is that clear? Yes, Aryan, you are correct. Aryan, you are correct. Some part of this was there in interference and diffraction, correct? So is this clear, guys? Do you understand this? So what you have done is you have done A plus A is equal to 2A. Now, let us take one more example very quickly. And this example, we can take opposite wave pulse. Yes, Aditya, correct. Bigger crest will be formed only momentarily. Then they will continue to travel in their original direction. Bigger crest is formed only momentarily, temporarily. After that, they will continue to travel in whichever direction they were moving. Okay, let's proceed. Come on, guys. This is the crest. Crest is moving towards right, and the maximum amplitude is A. This is a trough. It is moving towards left. Once again, maximum amplitude is A, but since it is downward direction, this is minus A. Now, can we say if the point here is P, both the waves are going to reach at P simultaneously? Both the wave pulse is going to reach point P simultaneously. So what should happen is, this first wave pulse will try to pull P in upward direction, and second wave pulse will try to pull P in downward direction. Now definitely the string cannot break. Correct, na? So how will the diagram look like when both the wave pulse 1 and wave pulse 2? When both the wave pulse combine, they are going to cancel out each other and the diagram will look like a straight line. The structure will look like a straight line. And therefore, the resultant amplitude of point P is going to be 0. So how did we get 0? It is A plus minus of A. That is what we did. So what have we done is we have done vector addition only. See, one is positive, other is negative, and we have added them up. Positive, negative addition. Vector addition. Do you understand this, everybody? Okay. Now, Prasad Joshi is asking us the question. Prasad is asking us the question, sir, what if the second wave pulse has different amplitude? See, Prashant, if the second wave pulse is having different amplitude, then we can say resultant amplitude is given by A1 plus A2. Okay, resultant amplitude is given by A1 plus A2. Okay, one more student is asking us a question, sir, if both the waves are traveling in the same direction, but the speed of first wave is more and meet after some distance, then what will be the direction? Now students, see, I have to answer all your questions. Please stop typing. At least let me answer these questions which you all have asked. See, I'm not able, the chats are going very quickly up. I'm not able to read your questions. So don't type right now. Let me explain the questions first. So the question is, sir, if both the waves are traveling in the same direction, but the speed of first wave is more and they meet after some distance. See, first of all, there is a conceptual error in this question. There's some student with name Carnage Loki OP. I don't know what that stands for, but any which ways, listen, there's some conceptual error in this particular question. If we are talking about waves, then in a single medium, wave cannot have two different velocities. In the same medium, wave cannot have two velocities. In the same medium, velocity is going to remain constant. Do you get this? So your question itself is wrong. Sir, if both the waves are of same material, correct? Both the waves are of same material. So their speed is going to remain the same. So there is a conceptual error in the question itself. Okay. Now I'm going to address the next question. What will happen after this? There is straight line. Will it stop or move further? No. Amay Parab. Once the straight line is formed, this straight line is temporary. It is momentarily a straight line. It is a straight line when both the waves have combined exactly at the same time. When both the waves are combined exactly at the same time. After this, what happens, you know? This wave pulse 1 will continue to travel towards right. And wave pulse 2 will continue to travel towards left. So like this it will happen. If you have a look at the diagram or my hand, movement of my hands, both the waves are coming towards P and at P they have become flat. And once again when they, after which they will once again continue as they were moving. Okay. Yes, Jagjit, resultant will decide whether it is crest or trough. Correct. Shantanu is asking, what if troughs travel from both the sides? Shantanu, it's same as previous case. If they both are troughs, then we are going to get a bigger trough whose amplitude is 2a in the opposite direction. Waves traveling in same direction will not be added. Abhidnya, waves traveling in same direction can also be added. Waves traveling in same direction can also be added. Okay, we are going to add it soon. We are going to learn about it soon. What if we keep the string in C-shape end? Sahil, your question doesn't make sense. I'm not going to answer that question. Pranav is asking, sir, does the distance between the point of contact and position of particle matter in resultant wave? Does the distance between point of contact and position of particles? Pranav, I'm not sure I'm understanding your question. Vaijanta, Chalke have already answered that if the amplitudes are different, then it will be A1 plus A2. Sir, if amplitude of crest is greater than trough, the result will be crest. Yes, Rishita. If crest is greater than trough, then the resultant will be crest. Let me show it to you all. It's obvious, na? It's obvious. Let me explain it to you all. This resultant is 5 meters and here the amplitude is 2 meters. So when you combine them at point P, when combination takes place at point P, so what will happen is we are going to get a crest whose amplitude is how much? 3 meters. Simple it is. Sir, what about rarefaction and compression? Atharva, same thing is going to happen for rarefaction and compression. Same thing is going to happen. Yes, Karthik, you are correct. Basically, resultant at only few points will be 0 if a crest and trough is traveling. Correct. Now Pranav is saying, sir, it means distance between point of contact and right side is more than that of left side. Will it matter from A? Now, first of all, guys, don't ask the same questions again and again. Everything that we are doing is temporary, correct? When they are combining, that combination is temporary. Waves are not going to stop. Energy is not going to stop. Do you get this? Energy is not going to stop. That combination is temporary. Pranav, if the distance is different, let's say point P is closer to the second wave. If point P is closer to second wave, in that case, if point P is closer to second pulse, in that case, combination at P won't take place. Combination at P won't take place. Then combination will be at middle point. Let us say the point is Q. We have to talk about simultaneous combination, superposition. Okay, I guess the video is becoming blurry. I don't know what the problem is. Frequent there is connectivity issue, students. I hope you all understand this. Connectivity issue is not in my hand. I'm trying my best to provide what we can. Okay. But nothing can be really done about this. Yes. So now, hopefully all your doubts are answered. Guys, I was solving doubts for last 10 minutes. 10 to 15 minutes was solving doubts. Now can we proceed? Hopefully there is no further doubts. I've cleared all the doubts that I can. Now some student is asking, sir, if wavelengths are different, then what to do? See, if wavelengths are different, it means the frequency is different. If wavelength is different, it means frequency is different. And I told you at the beginning, we are talking about same frequency, same amplitude. Towards beginning only we discussed about same frequency, same amplitude. Okay. So finally the concept of superposition, the definition is clear to you all. There shouldn't be a single inch of doubt as well. Okay, now students, in the examples that we have seen so far, can I say that amplitude of since amplitude during superposition changes. Come on, students. Students, I've written since amplitude during superposition changes. Therefore, resultant intensity of the wave also changes. Resultant intensity of the wave also changes. Resultant intensity of the wave also changes. I'll repeat what I've written. I guess the video is blurry. Guys, 1 second. All of y'all, stop typing. See, we can understand the video is blurry, hai na? So I'm going to repeat it for you all. I'm repeating it, na? So why are you typing again and again? It's blurry. If some student will ask doubt, how will I be able to see the doubt? Okay, I'm going to repeat. So stop typing and just write down, since amplitude during superposition changes, I'm dictating it all of y'all. Since amplitude during superposition changes, therefore resultant intensity of the wave resultant intensity of the wave also changes. Resultant intensity of the wave also changes. So whatever I have written, I have also dictated to you all. So hopefully you all have written it down. Okay. So there shouldn't be any kind of confusion. Students, I'm going to repeat for you all again. Don't worry. I'm going to repeat it for you all again. What have I written? I have written, since amplitude during superposition changes, therefore resultant intensity of the wave also changes. Now write down, because intensity is directly proportional to amplitude square. Intensity is directly proportional to amplitude square. Yes, Sahil has written entire thing in the chat. Thank you, Sahil, for this. Excellent, Sahil. After which, students, please copy this down. Intensity is directly proportional to amplitude square. Intensity is directly proportional to amplitude square. See, students, we all will be wondering that, sir, why are we studying superposition of waves? What is the real idea of combining the waves? What is the real idea of combining the waves? Okay, some student is asking, sir, notation of amplitude. Notation of amplitude is capital A. Notation of amplitude is capital A. So students, now write down superposition of waves gives rise to following phenomena. Superposition of waves gives rise to following phenomena. Okay, some student is asking us a question. Anmol Maurya is asking us, sir, why amplitude square? Anmol, there is a formula for this. Of course, the derivation of formula is not there in a syllabus. So you can just memorize that intensity is proportional to A square. After this, we have written superposition of waves gives rise to following phenomena. Once again, Sahil, thank you. Appreciate your efforts. Thank you, beta. Now, following phenomena. First phenomena is interference. Second phenomena is beats. Check the spellings properly, everybody. Third phenomena is stationary waves. Third phenomena is stationary waves. Jagjit, the formula is wrong. Intensity is equal to power upon area. The formula is wrong. Intensity is power on area. Yes, Darshan, correct answer. Darshan Joshi, correct answer. Interference, beats and stationary waves. Now, beta Sahil, no need to type for everybody because now I guess the board is visible. So I appreciate your efforts, but now beta, no need to take extra efforts, okay? Because everybody is able to see the board clearly now. So it is going to give rise to three phenomena: interference, beats and stationary waves. So that is the reason when you guys said that you have already done this in the chapter of interference. This is the reason behind that superposition is going to give rise to three phenomena: interference, beats and stationary waves, and all these are related to sound waves. What did I say, everybody? All this is related to sound waves. Okay, is that clear, everybody? Understood? Alright. Now students, we just have around 15 minutes left for the lecture. In this 15 minutes, we cannot complete one new topic. Will not be able to complete a new topic. So what we will do is, can we solve few practice questions on oscillation? In this 15 minutes, let us solve few practice questions on oscillations. Alright, everybody? So let me get the questions for you all. Alright, come on students. Okay, Rahul is asking, okay, before that Darshan was asking a question, sir, is this interference same as that in Huygens theory? No, it is different. That is for light, this is for sound, okay? Then Rahul is asking, sir, I had doubts in some questions from oscillations. Rahul, if you can type your doubt, I will be able to help you out with those doubts as well. Shantanu is saying, please take questions on particle passing through mean position. Sir, how am I supposed to give you the questions though? Rahul, if you can type the questions, if it's possible, type it. If not, then you'll have to request the group in which you are. You have to request the center coordinator to send me the doubts. Okay, you can send the doubts on your group and ask the center coordinator to send me the doubts. All right. Yes, I will clear your doubts, beta, but you have to tell questions. Okay. Veer is saying, I have doubt in exercise MCQ number 2 and 4 from textbook. Okay. Let me just go through those questions. So let me clear this doubt. Guys, now I'm solving doubts of oscillation. Now, Veer has asked us textbook question 2 MCQ. So let me explain this question to him. We just have to find maximum kinetic energy. Now, do you remember that maximum kinetic energy is given by the formula of half m omega square a square, correct? Now, when you compare the expressions, you can say amplitude is 6 centimeters and omega is 100 radian per second. Now just substitute both the values and you will get the answer. Mass is 1 kg. Veer, this is question number 2 for you. This is question number 2. Question number 4. Question number 4. Two identical springs are connected in series and then in parallel. A metal block of mass m is suspended from their combination. The ratio of their frequencies will be. This is very easy. Frequency is given by the formula 1 upon 2 pi under the root of k by m. So frequency is proportional to root k. Now k in series is k1 k2 upon k1 plus k2, and k in parallel is k1 plus k2. Now since k1 and k2 are equal, this becomes k square upon 2k, which is k by 2, and this becomes 2k. Now just substitute in this formula to get the ratios, okay? Just substitute in this formula to get the ratios. I hope it is clear now. Darshan is saying, sir, but this is potential, this is formula for potential energy. This is formula for maximum kinetic energy. Rishita is asking, sir, in chapter of oscillation, why the time period remains constant in time versus mass. Rishita, your question seems to be incomplete. If you're talking about pendulum, only the time period remains constant. If you're talking about pendulum, then only the time period remains constant. Sasmith is asking, sir, what is the formula to find path length? Sasmith, I've done one such question with you in the class. Path length means twice the amplitude. Path length means twice the amplitude. Sumit is saying, sir, if two waves meet in Y shape, then will the resultant be temporary or permanent? Sumit, I don't understand that. Why are you asking Y shape? Why Y shape? Is there any particular reason behind it, or have you seen that question somewhere? What is it? Okay, Rahul has typed a question. An illuminated particle executes a linear SHM of amplitude 1 centimeter along the principal axis of a convex lens of focal length 12 centimeter. The mean position of oscillation is 20 centimeters from the amplitude of oscillating image of particles. An illuminated particle executes linear SHM. Okay. So I'm going to answer to that question which who has asked? Rahul has asked. Rahul has asked one question. I'm going to solve that question for you guys. The question is very interesting. In that chat, you can find that question everybody. Rahul has asked. So, doubt of Rahul. I'm answering that. A particle executes SHM of amplitude 1 centimeter along principal axis of a convex lens. Okay, so we have a convex lens with us, and this is the principal axis, and a particle is executing SHM, and amplitude is given to us. Amplitude is equal to 1 centimeter of focal length 12 centimeter. Okay, focal length is 12 centimeter given to us. So let us say this is foci, and this distance is 12 centimeters. The mean position of oscillation is at 20 centimeters from the lens. Okay, mean position is 20 centimeters from the lens. Let us say this is the mean position. This is the mean position, and this distance is 20 centimeters. And particle is executing SHM where amplitude is 1 centimeter. We have to find amplitude of oscillation of the image. Now first of all, you can start by using the formula 1 upon V minus 1 upon U is 1 upon F. Okay, as per the data for first case, case 1 will be equal to, this shifts over there, so U image distance is at 12 centimeters. So 1 upon 12 minus 1 upon focal length. So now we'll say that the focal length is at 20 centimeters and then amplitude is 1. So we'll consider 21. 20 plus 1. If you want, I'll write 20 plus 1. Now if we solve this, 1 upon V1 will be 1 upon 12 minus 1 upon 21. 21 minus 12 is 9, 9 and 3, 3, 3, 3. This becomes, V1 becomes equal to 28 centimeters. V1 becomes equal to 28 centimeters. Do you get this? Copy this down. Copy this down. Why have we added plus 1 over here? Because amplitude is plus 1. Because amplitude is plus 1. So focal length is 12 and the object distance will be 20 plus 1. Okay, now case 2. Now case 2 is what is happening is 1 upon V2 will be equal to 1 upon 12 minus 1 upon 19. How have we written 19? 20 minus 1 because it is oscillating, so it can be here also, na? Particle can be here, particle can be here. So 20 minus 1. So 1 upon V2 will be 1 by 12 minus 1 by 19. And when you solve this, you get V2 as 32.6 centimeters. What do we have to find? We have to find amplitude of image. So we can say image amplitude is equal to 32.6 minus, how much was it? 28. And this becomes equal to 4.6. So this is the path length, image path length. Image path length is this much. Image can be here, suppose this is 32.6, or image can be here 28. So this is 4.6. So amplitude is 2.3. We get the amplitude as 2.3. So just copy this down, everybody. Yes, I know all of you are asking doubts, beta. Harsh is asking, and who else is asking? I guess Veer is asking, but beta, now we have reached towards the end. So I have to stop the lecture here, but I told you, Rahul, we already have a WhatsApp group, but I'm not able to solve doubts on the group because I'm pretty much occupied with lectures. Okay, so forming a WhatsApp group is difficult for me. I already have too many WhatsApp groups for the lectures which I teach in. Yes, even I already have beta, but it's difficult to address all the doubts. Okay. All right. Okay, students, we are going to end the session over here. So bye all of you all, take care and stay safe. Okay. Chalo, bye bye.